The electroscope is a device that is able to detect small amounts of electric charge. So the way an electroscope works is that it has a metal plate that connects to a central metal bar. In the center of the central metal bar is a pivot connected to a metal needle. So everything here is all connected together by metal. There's a metal frame around it, but it's actually insulated from the rest of the electroscope. So there's a piece of plastic here that insulates the frame from the metal bar and the top plate and the needle. So when we talk about the electroscope, we're talking about the top plate, the central metal bar, and the metal needle on a pivot. Okay? So if we were to charge a rod with a negative charge and bring it near to the top of the electroscope plate, what's going to happen is all the negative charges in the electroscope are going to travel down the central bar and onto the needle because they're repelling the negative charges from the negatively charged rod. So since they're all coming down here and the needle's on a pivot, all right, the needle's going to move because they're all trying to repel each other down here. Then all the positive charges from the electroscope are attracted to the negatively charged rod. So they're all going to collect onto the top plate. And that's basically how an electroscope works. So we'll take a hard rubber rod and rub it with some fur. That'll give it a net negative charge. Bring it near to the top plate of the electroscope, and we can see the needle moving because the central bar and the needle are all collecting the negative charges, which are being repelled by the negative charges in the rod. And then all the positive charges from the electroscope are collecting up on the top plate, attracting to the negatively charged rod. So this is an effect we call polarization. Okay? And if I actually touch the rod to the top plate, then the electroscope will collect that negative charge. So if I take a glass rod and rub it with fur, I'll give it a net positive charge. And then we'll see that the negative charged electroscope is now attracted to the positively charged rod. Okay? But if I bring the negatively charged rod back, we see that the needle deflects even more because it's repelling the negative charges in the rod. Okay? We can also induce a charge in the electroscope. If I charge up my hard rubber rod again, giving it a net negative charge, bring it near the electroscope, I'll see the needle deflect. I bring my finger and touch the top of the electroscope. And what that did was it gave the negative charges in the electroscope a pathway to flow to ground. Okay? So when I remove my finger, the electroscope has now been induced with a positive charge. Okay, so the electroscope is now positively charged, so it's attracted to the negatively charged rod. When I bring the rod away, the needle deflects again because all of the positive charges are spreading out throughout the whole electroscope and all repelling one another. So I bring the negatively charged rod nearby. It attracts the positive charges in the electroscope. I remove it, and the positive charges spread out and repel one another. If I charge the glass rod again with fur and give it a net positive charge, we see that the needle deflects even more because the positively charged electroscope is now repelling the positively charged glass rod.